Hello everyone. Today we are going to do something fun. So let's play around with graph and charts. So this is the beautiful parts of statistics. So this is to make your report look beautiful. Right? So when you analyze your data, this is the things that people are looking at, people are interested at. So if your graph and charts are not beautiful enough, so may not attract people's attention. So you miss your data, you miss the things that you want to say to people. So why do we need to visualize data? So graph and charts, we summarize data into something beautiful, into a graphic that explain our data clearly and effectively. Okay? So simply put, they make our data much easier to understand. But of course, we don't just making graph for the sake of making graph to make it beautiful. Now we have to have a purpose as well. So what is the purpose of your graph? What is it trying to tell? So what do you want to visualize? What kind of data? How can it be useful? What you are trying to explain with your graph, your charts? So these things you need to look at. So what is the level of measurement? Is it nominal, ordinal, or scale? Because different level of measurement, they may require different types of graph. Okay? So should they represented as frequencies, percentage, or density? So which one of this? So we need to think about all of this. Just now I have mentioned the level of measurement is important in making graph. Okay? So categorical data are grouped into non-overlapping categories. So this is quite common in your surveys because you are collecting information such as demographic information, age group, gender, any yes or no responses, race, faculties. To do this, bar chart and pie charts are most commonly used. Okay? And you also have Likert type items. So these Likert type items are ordinal in nature. So the best way to represent this is by bar graph. Okay? For continuous data, for example, the composite score and the exam score, all of this continuous data. So histogram is the most appropriate one. So you have to look at the level of measurement of your data. Then you decide which graph and you are interested to do. Okay? Let's look at the first one. This is the type of graph that you probably have seen a lot. So this is most effective when the variable is binary. You want to compare two sections. Which section is bigger? The bigger in this case contains more samples. Is it? Because most of the time, what people interested in pie chart, they are not interested in finding the exact number. Usually, they put a percentage. So you can put the exact number in the text section to explain this pie chart. But usually people do this because they want to know the portion of these two groups. Right? For this one, this group is 22%, this group is 77.79%. So whatever this is, you know. So of course, you need to label it also. And then if you have a lot of categories, maybe this one is 1, 2, 3, 4, 5, 6, 7, 8 categories, then it is a good idea for you to do a bar chart instead of pie chart. So bar chart is clearer to see. For example, this is count. Count means how many participants in each of these categories. Isn't this looks beautiful? So each bar, they have a small space here to differentiate between each categories. For example, this is 8 categories. So this is how your bar chart looks like. So bar chart is very simple, but it has a very strong visual impact. So because you can easily compare between each categories. From this, you know that the high number is for SPM, SKM, diploma, and bachelor. So the lowest number of participants is PhD. And after that, PMR and masters. So by looking at this, you don't need to look at the table. You don't need to look at the table and then to compute the differences and all. So when you look at this, you know exactly how it looks like. Right? So this is another type of bar. I cheated a little bit. I use Excel to do this. So the idea is that a group bar allow you to compare different data group for different value of variables. For example, this is 4 subject: maths, English, history, geography. And then this is the marks for 4 different classes: kelas merah, biru, kuning, and hijau. So you can do this one also, but usually people just use this one. Right? So this one I use Excel to do it. So it doesn't matter which tool that you use, as long as you can do what you want to do. It's okay. But histogram is like a bar chart, but it doesn't have space between those bars. So when this bar is combined, it will look like this. So why it is combined? Because this is a continuous data. So it should not contain any space in between, isn't it? So this is a histogram. We have seen histogram before. The histogram also show the data distribution. But the difference is that instead of count, usually histogram, it says here is density. Density means kepadatan. So if it is high, they meaning to say the frequency is high as well. So it reflects the same thing. So frequencies, count, percentage, density, it all reflects the same thing. How many people, how many sample. And so this is across the exam score. You know the exam score is a continuous variables. Alright, so that is histogram. You can put a line on top of this histogram and you call it a density plot. So density plot is this line. It may or may not have this histogram. Sometimes it's just a line like this. So it represents also the distribution of numeric variable. The same is histogram, right? And the higher the peak, it means the higher the frequency. The same thing. So it's just that this is in the form of line instead of histogram. Okay, so this thing can be plotted its own or with the histogram, but usually people plot it with histogram, right? So box plot, you have seen it a lot, right? Although it is simple, but it has a lot of information. So a box plot is also called a box and whisker plot. And box plot, as you know, is split data into quartile. First quartile, the median, and also the third quartile. And also you have the maximum value, the minimum values. So anything beyond this maximum and minimum is also is called an outliers, right? So these are the box plot for different groups. For example, this is male and female in terms of exam score. You can categorize it based on different categories as well. Okay, so there are a lot of things that you can try. You can try the violin plot. Is also a kind of Dropbox as well. But I would prefer this because it looks cleaner. Jitter is the messy parts. Jitter is the single data point plot it in this kind in this thing, so it can be very messy. But I like this one. This one you will do it when you do correlation and regressions. So later on we will see more of this. So scatter plot uses Cartesian coordinates x and y, and also dots. These dots to display the value of two continuous variables. So h against the score. So h and score, both of these are continuous variables. So when you have two continuous variables, then you can plot a scatter plot. So this is exactly what we will do later on, right? When we do a correlation and regression. You have seen this. This is a QQ plot. This is a line plot. And in regression, you will also do a regression line plot. But let's leave it to the regression chapter. All right. This is another kind of line, but this line here it shows the trend for 3 subjects over time. So, for example, this is exam score from year 1 to year 4. This is year 1, year 2, year 3, year 4. So this is some sort of like something that changes over time. So this is a popular in time series analysis, when something changes over time, when you measure something over and over again. So this can be represented with a line as well, right? I have mentioned regression line before. This is linear line. Linear is straight line, but regression line can be not a smooth one like this. Quadratic also. Quadratic is like a U shape or N shape. So later on we will plot that one. So this is the interesting part. This is done in Jamovi. Heat map is basically about correlations. So when we learn about correlation, maybe it will be clearer for you. So basically, we have here 5 items. We want to know whether these 5 items closely related to one another, positively related or negatively related. Okay. So, for example, this question 1 and question 2, this is 0.27. So we will leave. We will do this one later on. All right. So in a correlation chapter, maybe I will talk more about correlations. All right. So just beautiful. Just appreciate the beautifulness of this. This is something more complex. This is called faceting. So faceting is actually splitting the chart even more into several parts to categorize your data even further. For example, this one is exam score of male Bumiputra, female Bumiputra, male non-Bumiputra, female non-Bumiputra. So you can further categorize your data like this. Okay. So this is one example of faceting. So you have seen a lot of interesting graphs here. Let's try to make it. So here I'm using JASP. So doesn't matter how you pronounce this. So why I use this? Because while SPSS can make all of this graph, but the graph editing is done in the apps. And after you have done and you transfer it into word processor, the editing is difficult because you cannot use your word processor or your PowerPoint to edit the graph that you made. So imagine that you have already conducted all of this, and then suddenly your client say, oh, I don't want orange color, I want green. So if you use SPSS, you need to go back to SPSS and rerun it again. You edit it in the output. So this is something that we don't want. All right, because to change this, the one who can do this is the one who has the data. So if you can edit this in Microsoft Word or PowerPoint, then anyone can edit the graph, right? To make it more beautiful, may delete something, may add in some more things. ggplot2 is actually a package in R programming language. I have included some example of using this, but we're not going to learn about ggplot2. But if you are interested, I have some codes for you in the slides in the website. Maybe you can check that out. So JASP has a click and drag graphical user interface. The GUI means graphical user interface. So you don't have to do any programming, and also it is easier than SPSS. So in JASP, it allows you to export your graph into PowerPoint format. So you can edit it with PowerPoint. So as long as you know how to use PowerPoint, you can edit your graph freely. So it also supports vector graphic format, SVG. And so when you save your graph with this format, PPTX and SVG, your graph will not lose the quality. So you will not see that your graph is blurred. So your graph will always be sharp and beautiful. Okay, and JASP also allow you to do more complex graph, like faceting just now. This is done in JASP. Right? So I edit it. This is the outcome. Okay. And more importantly, this is free. This is free. You just download, install, and enjoy. Okay, so let's try to use this applications. So let's open JASP. JASP is more or less similar as Jamovi, just different look, maybe different color, but technically it's come from the same thing. So you just open the file. This one I use questionnaire data too, and you go to descriptive. So what do you want? So you can explore all of this. For example, these are the items. You can plot the distribution plot with display density like this. This is question 1. Question 2. So once you get this, you can export. You can click this small arrow here, save image as, and you can save it into PowerPoint. So let's save it in desktop so that easier for us. Okay, so give a name for this, maybe bar, and then you go to desktop, so it will save right here. So when you click this, so you can edit this. right? So maybe you want to change the fill. You don't want this color. This is horrible. So maybe I want purple color. Outline. I don't want to have any outline. And then I want a different shape of purple. Maybe this. Okay, so this is up to you to change. You can change these words also. You can change this, type the full sentences. So there are so many things that you can try. It depends on your creativity, really. So this is the distribution plot. You can also use. You can also try another plot, like you want to do score for different groups. For example, sex here. So let's see what we get. Okay, so you get density for male and female, and then you can also do a box plot. You can click it here. Then you get a box plot. So the same thing, you can edit this by saving this image into a PowerPoint. Say this is box. Wait for it to appear. Okay, then just change it however you want. Okay, for example, you don't know what is 1 or 2, then you can just type male, female. So it is so much fun doing this. If you want to do faceting, so you need something called a flex plot. So you need to have visual modelings. So if you don't have this, you can click on this plus here, this show modules, and then it will give you some options here. So you click on visual modeling, so it should be appear right here, and then flex plot. For example, you want to do this score based on race. You see, you get so many things. You can try with different things. So as long as it makes sense, then it's okay. Scatter plot. Yeah, you can put two variables in this side, and then you click on scatter. Okay, so it will show you this. So you can decide whether or not you want to add density over this one. If you don't want, you put none. Then density at the right side. Density at the right side means to say the density of age here. If you don't want that, click none. If you don't want this line here, you don't select this. Okay, so this is the scatter plot that you want. Okay, all right, so I will leave you to that. You can try different things. and I'm looking forward to see what you have for me, right? So happy trying, happy enjoying this. See you again next time.